Okay, so this is just a quick example of Dijkstra's algorithm. And then this is just a little bit more complicated than the one we did before. Um, and so you see some letters representing the nodes. And so A is going to be the node where we want to start at. And then basically what we're going to be doing is finding the distance to all the other nodes. Okay, so like we were doing in class, first we'll write down all of our nodes. So we'll take A, B, C, F, I guess I'm missing a few, F, G, H, and I. Okay, and since we're starting at A, we'll go ahead and put an A there. And so that'll be 0, so we always start with that box. Okay, so now we go to see which nodes A is connected to. So A is connected to B with a value of 14, so we can put 14 here. This is coming from A. A is also connected to H, which is 17. So that's in A. And then A is also connected to G with a 10. Okay, it's not connected to any others. Infinity goes into those spots. Good. All right. So now you take the value with the lowest number, and that's the one we're going to work with next. And so we see that 10 is the lowest, and so we'll bring down the 10. I like to just use the subscript to remember which the edge was that came from, right? Okay, and so now we do the same thing. Now the edge we're working, or the node we're working with, is G. Okay, so notice that once you see the box, right, you ignore this column. Okay, so now this is going to be boxed, and so now we're going to explore G. And so let's see, is G connected to C? G is not connected to C. Is G connected to F? G is not connected to F. G is connected to B, and so G is connected to B with a weight of 3. 3 plus the, you have to add it to the 10 here, so 3 plus 10 would give you 13, so that would be 13, and that's coming from G. Okay, let's see, so then G is G connected to C? No, it's not. G is not connected to F. Did I already go through those? So you just bring down the infinity on those, right? G is connected to H with a value of 6. 6 plus 10 is 16, so that's 16. 16 is less than 17, that's why we're bringing it down. And finally, G is connected to I with a weight of 4. 4 and 10 is 14. Okay, good. Now we'll have to kind of go back and forth a little bit. So now we go to the smallest weight. That's our smallest number is 13. So we bring that down. And that's going to be node B. Right, so now we're finished with node G, right? A and G are done. Okay, now from B, we want to see if B is connected to C. B is connected with C. Just suit. B is connected to C with a weight of 9. Right, 9 plus 13 is going to be 22. Sorry, I got something. As soon as I started to talk, I started to sneeze too, so for some reason something's going on. Okay, so then is B connected to F? Yes, with a weight of 10. 10 and 13 is 23. And so that's coming from B again here. Now that's finished, so we don't do anything there, right? And then do we do anything with H? B is not connected to H, so we just bring those down. And then B is not connected to I, just bring that down. Good. All right. What's next? Looks like the 14 is next. So we're going to be working with node I next. Okay, so let's bring the 14 down. And then we'll be working on I. Box that up. So there's not too many nodes left here. Let's see. I is connected to H with a value of 1. 1 plus 14 is 15, which is less than 16, so we'll go ahead and put our 15 there. and that's coming from I. Okay, let's see, is I connected to F? Yes, it is, with a weight of 7. 7 plus 14, is that 21? 21 I. And then is I connected to C? No, so the 22 just drops. Okay, good. Now the next one is going to be H, I guess, huh? And so we bring the 15 down, box it up. Okay, and now node H. Is H connected to C or F? H is not connected to either C or F, so those numbers just come straight down in the table. So H is not connected to C, H is not connected to F. Okay, and now we bring down the next number, 21. So F is going to be the next node that we consider. So is F connected to C? F is here, C is here. F is connected to C with a value of 2. 2 plus the current value of 21 would be 23. So we don't include that because that's bigger than the 22, right? And so the 22 just comes straight down. Good. And then finally, that just leaves 22 down here at the bottom with the node C. And we are done. Good. And so these box values are telling you what the distance is from A to each of the nodes. So the shortest distance from A to B is 13. Okay, that's coming from G. So let's check that on our graph here. So that's going from A to B. Yes, we see that going from A to B. You could either go this way, but that would be 14 units. It would be better to go this way and then this way, which gives you 13 units. And so that's what this is telling us right here. Okay, good. And similarly, you can get distances to all the other nodes. Very good. And then the other thing was that I just mentioned, right, that you could get a spanning tree out of this. So if you were starting at the node A here, we could put A on the top, and then we could take a look to see which node is closest to node A. Let's see. I think from our distances here, so remember I'm looking at the subscripts, and so I think I only see one subscript for A there, and so that's going to node G. So A to G is the smallest distance, and so we could just write our tree like that. Okay, and now are there any nodes with G's on them? I see an I here, and I see a B here. Okay, so node G is actually will connect G with a B and an I. Right, and then let's continue with the B then. Do I see any nodes with a B? I see one down here at the bottom. That's a C. So I could connect B to C. And then the last one is what's connected to I. I see I is connected here and here to G and H. So then I could connect I to G and H. Good. There you go. That's what's going to be called the minimum spanning tree. How many nodes do we have here? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Good. Yeah, so that's if you're doing some more work with minimum spanning tree, this is one method to get it using Dijkstra's algorithm. All right, so that was the example we did in class that maybe went a little too fast. We'll try one more example.